Hello friends, and welcome to week 5 for this course wastewater treatment and recycling. So far we have been talking different attributes of wastewater generation, its characteristics, its quantification, its natural attenuation, and we started discussing some of the engineering aspects, that how the concept of mass balance and those kind of things can be used or for designing a reactor or units which can engineerly treat wastewater. So, this week we are moving towards the treatment of wastewater, okay, the engineered treatment of wastewater, how the wastewater that we receive from municipalities or industrial effluents, how these wastewaters are processed and the quality of the water is improved by removing the various pollutants or various contaminants present in the wastewater. So, this lecture we will be talking about the basics of wastewater treatment, particularly municipal wastewater treatment, and then further we will start taking up one and taking up the unit wise what are the various units for the wastewater treatment, and we will have relatively elaborated discussions on each and specific units. Okay. So, to begin with, the when we see that we are talking about the wastewater treatment, what is the basic objective of wastewater treatment? Okay, why we are talking wastewater treatment? So, we have had earlier discussions onto this. Quickly you can see that the basic objective of wastewater treatment is to convert a water of this quality to a water of this quality. Okay. Of course, just by seeing this we cannot say it is a good water quality, but apparently it is looking much cleaner as than this. So, it is supposed to have much lesser degree of pollution as opposed to this water. So, wastewater treatment is processing or engineered processing of wastewater through a set of units which removes the contaminants from it, and in that context make the water quality better or improved. Specifically, if we talk about what are the basic objectives, so we know that wastewater is collected from various communities, okay, and should eventually be returned either to the natural systems, so receiving bodies like what rivers, lakes, canals, those kind of thing, or is applied for land or could be reused after making it safe for the purpose. Now, it should be either disposed of to the receiving waters or applied to land or reused only when it is ensured that there is no danger to human health or damage to the environment. So, this is one of the prime aspect, and this is what triggers the concept of wastewater treatment. Okay. The objective of wastewater treatment is to extract and remove the various pollutants and other toxicants that include suspended materials, dissolved materials, biological impurities which are present in the wastewater, and when you remove these, what you get the quality of wastewater which is improved, and then to what extent or to what degree it should be improved, that it should reach the permissible level of water to be discharged or reused. So, we intend to either discharge that water, dispose of that water, or reuse that water to what, so that is going to be the ultimate goal to which we should target our treatment. So, the degree of treatment which is required will eventually depend on the characteristic of the raw wastewater, okay, how the raw wastewater quality is, whether it is from municipal sources or it is from industrial sources. So, and what are the influent parameters, water quality parameters of the wastewater. So, all those things will be governing to what degree of treatment is needed, and then the desired quality of the treated water for disposal or reuse. So, what is the desired quality? So, we earlier said that idea is to reach the permissible level, and this permissible level actually is the desired quality. So, this desired quality is actually the permissible level, minimum desired quality is the permissible level. So, we must treat that water to the permissible level, and thereafter we can either dispose it off or reuse. So, depending on whether we are talking about discharge, we will need to look at the wastewater discharge standard. If you are talking about the reuse, so we need to bring the water to the water quality standards for recycling or reuse. And these standards are mostly governed by the state. So, our government has some body assigned, like in India we have Central Pollution Control Board. So, CPCB is the regulatory authority. CPCB puts the guidelines or recommends the standards as per or Ministry of Environment and Forest and Climate Change. So, they in in collaboration work out and develop a set of standards which needs to be followed when we are talking about reuse, recycling or disposal of the wastewater. The standards could be national, it could be different nation could have their own different standards, or it could be international standards also at times. So, for say the wastewater discharge standards in India, as per the Environmental Protection Rule of 1986, we have there is a schedule available and which talks about the different range or recommended range of the different parameters which should be followed when we intend to discharge the wastewater in our natural systems. So, depending on where we want to discharge, for inland surface water we have a different set of standards, for public sewers we have a different set of standards. If we want to use it like apply it on land for irrigation, or if we want to have a marine coastal areas. So, all those in total around 39 parameters are listed here, including color and odor, suspended solid, particle size, pH value, temperature, oil, grease, then nitrogen, different form of nitrogen, ammonical nitrogen, total nitrogen, free ammonia, biochemical oxygen demand, BOD. So, you see the BOD for inland surface water disposal limit used to be 30. It may not be readable, but then this is the source which can be looked upon, okay, and all these details is available there. So, you can always refer to the basic source and get this table. Okay. So, that way then there are different metals including arsenic, mercury, lead, the chromium, copper, zinc, selenium. So, a variety of contaminant and pollutants are listed in this table, and if we intend to put water for inland surface water disposal, we need to meet these standards. If we want to apply it to land for irrigation, we need to meet these standards. So, that way we have a set of standards available. Okay. These standards are amended also from time to time, like the latest amendment took place in the last year when these environmental protection amendment rules were passed last year. So, here the basic change is the biochemical oxygen demand, which was in the range of 30 was reduced to 20. Okay. The total suspended solid was brought to less than 50 milligram per liter. Okay. BOD limit is still 30 for areas other than the mentioned above. So, there are all metro cities, state capitals, all those areas are mentioned. So, for these areas the limit has been reduced to 20, and for excluding these areas the limit is still 30. So, that kind of like amendment or these things keeps on coming. We can make stringent more stringent standards. So, depending on how is the technological advancement, to what extent we can achieve these values, because standards should be achievable also. We cannot keep a standard which is very difficult to achieve or which requires enormous amount of money or fund for treatment. So, that probably would people would avoid achieving that. So, standards are set keeping in mind the achievability of those standards. Okay. And that is why different nations or different agencies, world agencies, state agencies could have different standards as well. There are wastewater reuse standards as well. So, like the US EPA or USAID guidelines, Agricultural Department and Environmental Protection Agency guidelines are there for urban reuse. Let us say these are some of the set of parameters provided. Then for reclaimed water monitoring we have, okay. Then for agricultural reuse we have some set of parameters, agricultural reuse for food crops we have certain set of parameters, agricultural reuse for non-food crops we have certain set of parameters. WHO also present its own guidelines for the wastewater use in agriculture. So, these are the microbiological guidelines. So, the pathogens and fecal coliforms, what should be their preferable range if we intend to reuse that. Food and Agricultural Organization of WHO also has presented some of the standards. So, for different elements, okay, what is the recommended limit for irrigation reuse. Similarly, for various other parameters, sodium adsorption ratio, various metals and this kind of thing, depending on the whether it is going for surface irrigation or sprinkler irrigation, some of the parameters are suggested. So, that way the point, like no one is expected or supposed to remember these values always. These are present in the open public forum, okay, and whenever need one can refer that. The idea of presenting it here is that this kind of standards are available, okay. So, people who are in this field must know that where to look for such standards. If you are, let us say, planning a wastewater reuse, so you should refer to the adequate standards. The reuse standards may or may not be available for all the nations. So, like in India we have very limited standards for reuse purpose, okay. However, we are encouraging more and more reuse options, so slowly it is coming now. Then so, in order to meet these standards, in order to bring the water quality from its raw characteristic or the polluted water to the reusable or dischargeable water, we must provide treatment. So, this treatment is typically provided through various processes or various treatment units, okay. So, if we talk about the wastewater treatment processes, so a typical wastewater treatment plant will have several unit processes and unit operations, okay. So, it actually encompasses various unit operations and unit processes. The treatment methods in which the application of physical forces are predominant, okay, are called unit operations. So, the processes which, let us say, works on predominantly physical forces, okay. So, for say the settlement of the coarse material, settlement of the sediments, so that is settling by virtue of gravity because of its weight. So, there is no chemical reaction or biological reaction is involved. So, it's this kind of processes are called operation, unit operation, okay. So, unit operation are the basic physical processes, and this primarily involves physical separation of the pollutant that are there in through the screening, grit chamber or sedimentation, okay. We will talk about in the detail what are screening, grit chamber and sedimentation processes. Then we have the unit processes, okay, which the unit operations are the one which works on physical principles. Similarly, the unit processes are the one which have chemical or biological reactions predominate the process. So, the pollutant is chemically or biologically transformed or degraded generally to smaller compounds, okay, which is your examples would be the biodegradation or chemical degradation steps, okay, like we did talk about the BOD reduction and all that. So, that is a biochemical reaction that is taking place. So, those kind of units or those kind of methods are called unit processes. So, that is the basic difference between unit operation and unit processes. Now, since the municipal as well as industrial wastewater contain various physical as well as chemical pollutant, and many of them are treated or removed through physical means, while for particularly the organic waste and those kind of compounds, we need biochemical reactions, okay, to decompose or degrade them. So, a typical treatment plant often combines several unit operation and unit processes, okay, and that will be needed for the complete treatment of wastewater. If you are just doing with a few select units, you may not deal with all type of contaminants present, okay, because something which is dissolved in the water, let us say dissolved organic matter, will not settle out, you keep it for howsoever long. So, if you try to remove that with sedimentation or screening or those kind of things, it is not going to work. So, we need dedicated processes for that, and for a good treatment or for a complete treatment of wastewater, a combination of various unit operations and unit processes are typically required. So, if we see the municipal wastewater treatment, there are variety of processes, and there are these are generally classified into various steps, okay. So, there would be preliminary treatment, primary treatment, secondary treatment, tertiary treatment, those kind of steps are there. So, preliminary we have screening, comminution, grit removal kind of processes are the preliminary treatment. Primary treatment is primarily the sedimentation or the primary sedimentation, which is also known as primary settling, okay, or primary clarification. Then secondary treatments are mostly biological treatment processes, okay, where the waste, organic waste is decomposed of, okay, or BOD and COD is reduced. So, these are primarily the biological systems, could be aerobic, could be anaerobic, could be low rate process, high rate process. So, there are variety of options available, but those will eventually fall in this. And then the separation of the biosolids produced from the water is also a part of secondary treatment, which is called secondary settling, okay. And then we have tertiary treatment, which is also referred as advanced treatment. So, here depending on the need, we can select, we can go for the advanced processes, which could include variety of processes, including advanced oxidation processes, membrane processes, nutrient removal processes, disinfection, this chemical settling or neutralization kind of processes. So, depending on whatsoever left post secondary treatment, and if you want to treat that, so how we go, that will be based on the advanced or the tertiary treatment processes. So, this preliminary and primary treatment, so many references or many books, if you see, they club these together and just refer this as a primary treatment. So, in few places you will see that 4 categories: preliminary, primary, secondary and tertiary or advanced, and in some places you will see just 3 categories: primary, secondary and tertiary. So, in those cases this preliminary and primary both are clubbed and are typically referred as primary treatment. Now, what these different steps do, okay, what are these different stages? So, preliminary treatment is for screening of large floating materials and removal of grits, that is the objective of preliminary treatment, okay, which is done through screening and grit removal. Then we have primary treatment, which is the physical settling of insoluble solids, okay, which are there in the wastewater, that is typically referred as primary settling. Then we have secondary treatment, okay, which is the biological treatment followed by the secondary clarification for the separation of these biological solids from the main wastewater stream. So, the basic biological treatment will try to remove the organic matter present, dissolved organic matter present, and in the process the biosolids which are produced are separated by secondary clarification. So, these are the secondary treatment processes. And then we have tertiary treatment, which is also advanced treatment. So, tertiary treatment or advanced treatment are actually the treatment that is followed after secondary treatment, and it is usually for the removal of either nutrients or high total dissolved solids, microbial pollutants. So, whatsoever are left after secondary treatment, is actually removed or treated through this tertiary treatment process. So, these are the basic objectives of the various treatment stages. Okay. And then as we said that many places these two are clubbed. Okay. Then we have the like that way with a combination of these different units we can set up a entire treatment plant, we can set up a complete treatment plant. So, what you see on the screen is basically couple of treatment plants, the aerial view of these treatment plants. So, this one is from the Nagpur. Okay. This is a Nagpur wastewater treatment plant, and this is one of the treatment plants in the state of Indiana in the US, okay, which is South Bend wastewater treatment plant. So, this is how these treatment units or assembly of treatment units looks from the top. So, you will see here there are various units, there are some smaller units over here, then there are these units for clarification this thing, and then there are these units, these a series of units are there. Similarly, here you will see that various types of units are aligned at various places. Okay. So, this way a combination of units will give the entire or will sort of make the entire treatment plant for the treatment of wastewater. So, we will end this lecture here, and in the next class we will start taking these different treatment units one by one. Thank you.